Today, we're jumping into the secret history of artificial intelligence. And believe me, it's not just a story about code. It's a 60-year roller coaster ride, full of incredible highs, some really crushing lows, and a kind of philosophical war that shaped the tech that is, well, completely changing our world right now. So picture this. It's the 1970s. People have poured millions of dollars and years of work into the dream of automatic language translation. And this quote, this was the final verdict. It was a total failure. It basically became the poster child for AI's overhyped, broken promises. It looked like a complete dead end.
And yet, here we are. That impossible dream is something billions of us use every single day. So that prediction wasn't just wrong, it was spectacularly, fundamentally wrong. So what on earth happened? How did we get from that dead end to the ridiculously powerful tools we all have in our pockets? To get that, you really have to go back to the beginning.
Okay, so our story starts in the 60s and 70s. And you have to understand, this was a time of massive optimism. The very first computers were seen as these perfect logic machines. And the thinking was, hey, any problem, even something as complex as human intelligence, we can solve it if we just write down enough clever rules. Now, these early AI pioneers, they weren't trying to build a machine that could think about, everything. Their goal was way more focused. They wanted to create what they called expert systems. Think of them as programs designed to become world-class specialists in one single, incredibly hard task. And a program called Dendrol out of Stanford was this huge early success. Its only job was to help chemists figure out what unknown molecules they had from lab data, which for a human is a super tedious, brain-twisting job. But Dendrol, it did it with the speed and the accuracy of a human expert. And this felt like a massive breakthrough. It was like, wow, this is proof. A machine can actually think, at least in its own narrow way. But the ambition of these early systems, well, it ran smack into a giant brick wall. Critics started pointing out that successes like Dendrol only worked in what they called playpen worlds, these really clean, simple environments with a fixed set of rules. The real world, they said, is infinitely more messy and complicated. And the core problem was this thing called the combinatorial explosion. It sounds complicated, but it's pretty simple. It just means that as you add even a little bit of complexity to a problem, the number of calculations you need to solve it doesn't just go up a little, it grows exponentially. It just explodes. And pretty soon, even the biggest computers on the planet were totally overwhelmed. And that realization caused the hype bubble to burst, and burst hard. Big government reports came out and convinced everyone to pull their funding. All that public excitement just vanished, and it was replaced by this deep, deep skepticism. The whole field went into a deep freeze that we now call the first AI winter. But, during this quiet, frozen period, there was this fundamental debate that had been simmering for years, and it just boiled over. It was a clash between two totally different philosophies for how you should build a mind. And a great way to think about it is the architects versus the gardeners. So on one side, you had the architects. This was symbolic AI. They believed intelligence had to be built like a skyscraper. You carefully design it, you program every single rule, every piece of logic, from the top down. Then you had the gardeners, from the school of connectionism. They had the exact opposite idea. They said, no, you plant a simple seed, like a network of artificial neurons, and then you grow intelligence by feeding it data and letting it learn from the bottom up. And in this early model, the architects were absolutely dominant. An influential professor at MIT, Marvin Minsky, published this devastating critique that mathematically proved that the gardeners' simple neural nets were just incapable of solving some really basic problems. I mean, the book was so damaging, it basically killed almost all funding and research into that approach for more than a decade. So, with the gardeners and their whole learning-based approach pretty much out of the picture, the 1980s saw this huge comeback for the architects' symbolic AI. All of a sudden, AI wasn't just some university research project anymore, it was a hot commercial product all over again. This was really the first great AI gold rush. This new industry of knowledge engineering just exploded, promising to build expert systems that would revolutionize everything from medicine to finance. Companies poured billions in, and whole countries like Japan launched these massive national projects, racing to build the world's first true thinking machine. But they slammed into the exact same wall. These handcrafted systems were incredibly brittle, meaning they would just break the second they saw a situation that wasn't explicitly covered in their rules. And even worse, they were astronomically expensive to maintain. The world changes, and nobody had factored in the crippling cost of constantly having to update millions of lines of code by hand. Yeah, the result was pretty much inevitable. The roller coaster plunged down once again. By the late 80s, the hype was gone, the commercial promises were broken, and the funding just dried up completely. The second and even colder AI winter had arrived.
But while the world was basically writing AI off as a total failure, a revolution was quietly brewing in the background. See, the gardeners, who'd been kind of toiling away in the academic wilderness for years, were finally about to get the tools they needed to make their seeds grow.
So, three crucial things came together that changed everything. First, this algorithm called backpropagation gave neural nets a way to actually learn from their mistakes. Second, the internet provided a literal ocean of data for them to learn from. And third, powerful gaming chips, GPUs, turned out to be perfect for the huge calculations needed. And all these threads came together in 2012 when a model called AlexNet just shattered records in an image recognition contest. And that was the moment everyone realized, oh wow, the gardeners are back. And this just shows you the incredible new scale we're talking about. We went from those small hand-coded systems to models like GPT-3 with 175 times billion tunable parameters. You can think of those parameters as tiny little knobs that the model adjusts all by itself as it learns from data. It was no longer about writing rules. It was about creating a vast learning architecture and just letting it absorb the patterns from basically the entire internet.
Which, of course, brings us to today. The technology feels radically new, but if you listen really closely, you can hear the echoes of all those old debates, the same exact hopes, and the same warnings from decades ago.
I mean, just think about this. The very problems that top experts in the 70s said were fundamentally impossible are now solved. Lighthell was sure a computer couldn't master chess by logic alone. And you know what? He was probably right. But decades later, Deep Blue learned to do it a completely different way. See, the skeptics weren't wrong about the limitations of hand-coded rules, but they were completely wrong about the potential for a machine to just learn on its own. The entire history of AI has been this dramatic cycle of euphoric hype and then this bitter reality check. And it forces us to ask a really critical question. Is this time actually different? Have the gardeners finally broken the cycle of boom and bust? Or, after the longest climb on the roller coaster yet, are we just about to face the biggest drop of all?